Hello guys, welcome to one more video from GATE 2020, and this is question number 32, which is a matching. So here you can see in column 1 they gave the different techniques like blast furnace, Hall-Héroult process, basic oxygen furnace and Crolles process, and on column 2 they gave their mechanisms, the principle of working behind these particular processes. Okay, so what is happening in this? So basically, what is blast furnace? What happens in a blast furnace iron making process? We use carbon, okay, or we use coke as a fuel or a reducing agent. Okay, so we use that so that this will be reducing your iron ore. That means wherever we use carbon, okay, or carbonaceous materials as a reducing agent, we call it carbothermic reduction. Therefore, the blast furnace will match to the carbothermic reduction. What is Hall-Héroult process? So Hall-Héroult process is a technique where, of course, it is an electrometallurgical technique where we try to extract aluminium from alumina. Okay, so it is basically nothing where Al2O3 actually is fused with something called as cryolite. So two different, cryolite is a salt which is actually used for various reasons like decreasing the melting temperature, improving the conductivity of alumina, which is Al2O3. So Hall-Héroult process is nothing but a fused salt electrolysis technique, which is option 4. And what is basic oxygen furnace? We know what happens in a basic oxygen furnace or an LD converter. Basically, we make the hot metal from iron making or blast furnace technique, and we convert the iron into steel by injecting oxygen, okay, by blowing oxygen, so that whatever carbon that is present, typically in iron the carbon content varies somewhere about 3 to 3.5%, but in steel you don't want that much. Okay, in the steel that we use for regular daily applications, you require somewhere between 0.1-0.2% of carbon. So how you will actually remove that? You basically remove that by blowing oxygen. Okay, you blow oxygen so that whatever carbon is present, it will tend to react with it and it may form either CO or CO2. Okay, so the carbon is actually reduced out. So if you see, basically this is an oxidizing technique, whereas in blast furnace it is my reducing technique. There is reduction taking place in blast furnace from ore to iron, and in steel making you are actually oxidizing. Okay, which is interesting, right? First you are reducing and then you are again oxidizing, because the purposes are different. The purpose in blast furnace is to extract iron, whereas here the main purpose of steel making is to refine your iron, okay, by reducing out your impure materials like silicon, aluminum, phosphorus, carbon. All these elements has to be removed out, and how you will be actually oxidizing them. Okay, so your basic oxygen furnace is an oxidation technique. And what is the last one that we have is a Crolles process. So Crolles process is a commercial technique, I would say, which is used to extract titanium. Okay, so basically Ti6 TiCl4 is actually reacted with sodium or most of the cases magnesium to form titanium and MgCl2. Okay, this is a basic equation of Crolles process, okay, or extraction of titanium. Okay, so what is metallothermic reduction? Here, because carbon is used as a reducing agent, we are calling it as a carbothermic reduction. Whereas when a metal, some other metal, so here to reduce your titanium chloride, we are using some other metal, magnesium, and these are called as my metallothermic reductions. So your Crolles process is a metallothermic reduction. So what would be your options? P goes to 3, Q is matching with 4, R is matching with 2, and S is matching with 1. 3, 4, 2, 1 is your option, which is option C. Okay, so this is kind of a overall summary of what are the different mechanisms that take place in different techniques. Okay, there are various other techniques. I would suggest you to actually go and study about them, at least the working principles and what is the purpose of it. So that's it for this video. We'll meet you again in the next video, guys. Thank you.